Hey, hi friends, welcome to today's video. So today I'm going to discuss about generics in Kotlin. Now this video is going to be in two parts. So in this video I'm going to focus on the basics of generic, and in the next video I'm going to focus on the advanced concept of generic. Now if you see here this definition, generic are the powerful feature that allow us to define classes, methods and properties which are accessible using different data types while keeping a check of the compile time safety. Okay, now here this line is actually important: compile time type safety. Now what is this? We're going to discuss in a while. Now if you see the this definition of list of, so you can see it here. So what is basically, it's a function which takes element of type t or varag elements, and then it returns you a list of t. Now here this t is basically denoting a generic type. Okay, now you can write even your own function which takes a varag element and returns you a list. Just similar behavior to what we are getting with this list of. So let me write that function. So fun my list of, and then what I'm going to do, instead of this integer we can take the type as any. So varag, and then we have the argument as elements, so let's keep the same argument elements, and then type as any, and then this is going to return you a list of type any. Okay, and what we are going to return, we are going to return elements dot as list. Okay, now instead of creating the list using this list of, let's say I just call, instead of subscribe, call it as numbers 1, and this I can call it as numbers 2. Okay, and this is going to be of type of my list of, and I'm going to pass the same element. Okay, so till now there is no problem, even I'm using this list of, or I'm going to use my list of. Now here if you see, when you're using generics, so we are actually in this case telling the compiler that hey, in this case I want to behave that generic as a integer. So that's the reason that we are passing this as an integer value. If you pass anything as a string, you will get a compile time error because this type is integer. So if you make it a string, in that case it will give you error in this two scenario, because in that case it want you to pass the value as strings, not as integer. Okay, now let me write some piece of code, and then we'll understand that what creates a problem when we use any instead of a generic. So now if you see this code, what I'm doing, basically I'm just running a for loop and I'm adding the numbers in this list. Okay, and I'm just printing it here, and the same thing I'm doing with my numbers 2, which I'm creating with this my list of function. But in this case it is throwing you error when you are trying to add this number. Now why it is throwing you error? If you try to see the type of num, it is telling that it's any type. But if you see the type of num here, it is of integer type, and someone is also integer, so you can easily add two integers because you can always perform this arithmetic operation on the same operators, on the same type of numbers. And in this case this num is any and the sum2 is integer, so that's the reason that this is not happening. Now one thing what you can do some sort of unwrapping here last, and you can convert this to integer, and now you can see that error is gone, and if you run this you will get the output 6 in both the cases. Okay, now this works fine, this function also, but you have to perform this typecasting every time when you do. Okay, and the problem here is what happened, that see, now my intention was to form an array of integers here, right? Like we are passing 1 2 3. Now here also my intention is to form an array of integer, but what if you pass a string also here, and in this case see, you are not getting any error, right? Because the type is any, so it can accept any type. And now the problem will happen when you run the code, it will crash, because here we are trying to convert this thing to as an integer, and then this is a string value. And see, you can see the error message also here. and you can read this line that class java.lang.string cannot be cast to class java.lang.integer. So it can give you a extra sort of issues when you're trying to use and doing some sort of typecasting if you're not sure. Okay. Now instead of this typecasting, what we are going to use, we're going to use a generic type, the way it was used in the collection here. Okay. Now there's no hard and fast rule that what you write, you should write T or whether you should write V. It all depends on you. But T is what you standard in any language. Like even if you see the language in Swift, there also we have generic, and there also we use T. And here also I can tell that it's going to return T. And one more thing here, we have to tell the compiler that it's a generic function. Okay. Okay, now let's try to run this, and now this is not required because we don't require any sort of casting here. And if you run right now, it should work, right? See, you are getting 6 in both the cases. So one question can come here that here I'm not giving the type, but in this case we are telling the compiler about a type. What if I remove this type? I should not get any error, because once you pass the value, the compiler will understand from that value that what is going to be type. So if you're defining any object without initializing at that point of time with some value, even the type is not necessary. Okay, you can just write it, and the compiler is well smart to understand that this is going to be of integer or it's going to be of a string. So generic is not just limited to a function or variable. You can even create your own generic classes. Let's say for example, I can write a class here, box, for example, and then this is of generic type, and let's say that this takes some input. Let's say I just call it as input, which is of type T. And here I can have a object input which is going to be of type T, and then in the init method what I can do, I can write this dot input equals to input, and I can also give a print statement so that it will print me whatever the value that I'm going to initialize. Okay, so I print this input. Now it is giving some sort of suggestion here. Let me see what's the suggestion. So we can make this private because I'm not accessing it from the outside. Okay. Now this class becomes a generic which is expecting a generic parameters. I can pass integer, string, whatever I want. So let me try to create the object of that class. Let's create the object. So val obj1, and this is going to be of type box, which is going to take in the first case integer, and then we can initialize the value of this box, and I can pass the input, right? And what is my input value? Let's say that in this case I can pass 140. Okay, similarly I can create another object of obj2, and in this case instead of integer I can take a string, and I can pass some string value, hello world. Okay, so this is the way how I can use the generic classes to have a generic parameter and then accept different values. So generic code are actually very helpful in writing a reusable code. Like instead of writing multiple functions, multiple methods for the same thing, I can use generics to actually make the code less, not like duplicate, and make the code more reusable. Okay, we are going to discuss generic more in our next video. So if you have not subscribed the channel, then please do subscribe it. Thanks for watching. Thank you.